Assalamu alaikum and hello everyone. In today's lecture, we will learn how to evaluate two mutually exclusive projects with the help of expected cash flows, standard deviation, and coefficient of variation. In this lecture, we will also learn how to calculate risk adjusted NPVs. So let's begin with the problem number 12-12 from the book Fundamentals of Financial Management by Brigham Houston, and we have this problem in front of you. So the company must decide between two mutually exclusive projects. So first of all, we should know that what does we mean by mutually exclusive projects. So mutually exclusive projects are basically the projects, or you can say these are the situations where selecting one project automatically exclude the possibility of selecting the other project, or in simple words, we can say that only one project can be considered due to resource constraints or financial limitations, or you can say other strategic considerations. So whenever we have mutually exclusive project, 3 points must be remembered. First of all, select one single project and reject all other projects. The other thing, which is these are competing alternatives, which means that projects serve very similar purposes or achieve similar objectives. And the third one is their decision criteria, which is based on the metrics like net present value, IRR, or payback period, and so on. So, mutually exclusive projects are very common in capital budgeting decisions where firms aim to maximize shareholder value while working within resource constraint. So these two project A and project B, are mutually exclusive. Each project cost $6,750, means this is your cash outflows for each project, whether A or B, and has an expected life of 3 years. Each project has the expected life of 3 years. Annual project cash flows begin at year one after the initial investment, which is $6,750, and are subject to the following probability distributions. So we have project A, and you can see here we have different probabilities and then cash flows, and similarly we have B, and its probabilities and cash flows are there. So the company has decided to evaluate the riskier project at 12% and the less risky project at 10%. So, first of all, we will have to determine which project is more risky, because more risky project will be evaluated on um, 12% rate of 12% rate, whereas less risky project at 10% rate. So, in requirement number one, requirement is expected cash flows, then standard deviation and coefficient of variation. So, expected cash flows, A and B, both are not given, so we will find it. And then project B, the standard deviation and coefficient of variation is given. So this need to find out standard deviation and coefficient of variation of project A only, but we will repeat these procedure for project B also, so that we know that these values are okay or not, or if in your exam, if these project B standard deviation or coefficient of variation will not be given, then how will you calculate? So first of all, we are going to calculate these three basic calculation. For this, we should know that what are expected cash flows. So, expected cash flows represents the weighted average of all possible cash flows from a project, where each cash flow is weighted by its probability of occurrence, or chances or possibilities of occurrence. So it gives a single value summarizing the project's cash flows considering the likelihood of various scenarios. So what we are going to do, we will simply multiply the probabilities with their cash flows to get the expected cash flows, or this is also known as expected average cash flows. The second thing is the standard deviation or sigma. The standard deviation measures the amount of variation or dispersion in cash flows related to their expected value or the mean values. So, the higher the standard deviation indicates more variability or the higher risk, whereas a lower standard deviation indicates more consistent with cash flows. If the standard deviation is lower, this means that the risk is also lower. And the third one is variance. Variance is the square of standard deviation, and variance quantifies the spread of possible cash flows around the expected values but does not provide intuitive units. So it's in square term, means variance is basically square of standard deviation. So it is useful for intermediate calculation, but standard deviation is more important since it has the same units as cash flows. Means cash flows, if cash flows are in dollars, then this means that variance standard deviation is also in dollars, and so on. And the last calculation which is required in the in 12.12 problem is coefficient of variation, and it compares the level of risk to the expected returns. It is used to assess risk per unit of return. So the formula is the risk divided by the return. A lower coefficient of variation indicates a more favorable risk return trade off. So these four calculations are required in the problem. So here we are back to the problem and project A. And for project A, probability is given, or you can say P is given, which is 0.2, 0.6, and 0.2. And then cash flows are given. Cash flows are $6,000. Then we have 6750, and then we have $7,500. So first step is to calculate the expected cash flows, and as the definition suggests, expected average cash flows, which we will get by multiplying cash flows with their respective probabilities. So E stand for expected cash flows. And here we have zero point 0.2 and multiply by 6,000 means we are multiplying this. And again, we have 0.6 multiplied by its cash flow, which is 6750. In the third example, in the third line, we have zero point 0.2 multiplied by $7,500. So these are expected cash flows, and we are going to take some of these. So $6,750. These are, here we have a dollar sign. So this is the first requirement, um, requirement A, in which we have calculated uh, expected cash flows of project A. Similarly, we are going to repeat the same calculation for project B. And in project B, the cash flows which are given is 0, 6750, and then we have $18,000. So here we have, instead of 6,000, we have 0, then we have 675, and then in last we have 36, we have 18,000. So we are going to multiply it by 18,000. So this is expected cash flows of project A and project B. The second requirement is a standard deviation. So for standard deviation, we need to calculate further calculation, which is the cash flows minus expected cash flows. Here we have cash flows are in first case cash flow 1200, and expected cash flows are here 6000. So 6000 minus the expected cash flows, which is 6750. So we have 6750. And the next we have cash flows, which is 6000. 6750 minus expected cash flows are 6750. And the next we have expected cash flows are 7,500 minus expected cash flows, which is 6,750. So expected cash flows are constant each year, whereas cash flows changes as the probability changes or the scenario changes. Then we take the square of like here cash flows minus expected cash flows, and then we take the square of it. So here, so in this way we have minus 750, and now we are going to take square. Then we are going to repeat all these. Here we have square root of 0, and then we have the same amount. Here minus, we don't have minus, but we have a positive value, but because of this square, the answer is same. And in the next step, we multiply this answer with the probability, which is this one. So we are going to multiply P into CF minus expected cash flows and square. So we have probability is zero point 0.2, so 0.2 multiply CF minus expected cash flows square, which is 562,500, and all these amounts are in dollar. And then as it is 0, so answer would be 0 again. And then we have here you can see the probability is 6, and this amount is 0. And then next case probability is again same, whereas the amount is same. So this is same. So when we add these, next step is to add these amount, this one. So here we are going to calculate standard deviation of this amount. Uh, so next requirement is we take standard deviation. So standard deviation is simply we take a square root of this amount. So we have formulas and functions, and you can do it on your calculator. So we have square root, and the amount is this one. So this is your standard deviation, and it as these amounts are in dollars, all these amounts are in dollars. So this answer would also be in dollars. Here we have dollars, and this is the standard deviation. And next one is coefficient of variation, and which the formula is coefficient of variation is standard deviation divided by expected return. So standard deviation is 474.34 dollars. divided by expected cash flows, which is 6750. So uh, this is coefficient of variation. So here it is our next answer, coefficient of variation of project A. So the next requirement related to project B, although standard deviation and coefficient of variation of B is given, but we are going to calculate it by ourselves. So let's see, expected cash flows. Cash flows minus expected cash flows. So in first case, expected cash flows are 0. Then we deduct um, expected cash flow, which is 3650. So 7650. And then second case, cash flows are 6750 minus expected cash flows, which is 7650. And then we have 18,000 cash flows minus expected cash flows 7650. So this is cash flows minus expected cash flows, and then in next step we take square of it. So the next step is cash flow minus expected cash flows, and then we take square of it. So the expected cash flows are here cash flows minus expected cash flows, which are minus 7650, and then we take square of it. Similarly, we are going to repeat these exercise for the remaining. Here we have minus 900, and in last we have instead of minus, we have positive amount, which is 10350. Now, in the next step, we are going to multiply this with probability. So uh, we are going to copy it. So multiply it by its probabilities. So these are the probabilities, which is 0.2 multiplied by 58. Here we have 58522 in first case. In the second scenario, we have zero point 0.6 multiplied by 81 810000, and in the last we have a zero point 0.2 probability, then multiplied by 107 122,500. So here now in the last step, add all of these or take summation. Here we have this amount. So the next step is to calculate standard deviation and coefficient of variation. Project B. So standard deviation is this one. It is the cell number is this one, which is P15. So standard deviation is P15. So why this one? So this is a standard deviation, 5797.8. So here you can see this is almost similar. Point 8 means 5797. So here both are same. And then coefficient of variation is you have standard deviation, which is 5798 divided by expected return, which is you can see 7650. So 7650. So this is the coefficient of variation of project B. The next requirement is to calculate. Oh, okay, you can see that this coefficient of variation is similar as this is as it is provided by the problem, 0.76, and here we have 0.7579. So just when we take only two digit, you can see we have only two digit, and here again, um, we are excluding cents. The answer is same in both cases. You can check it with the problem. It is given in the problem. The next requirement is based on the risk adjusted NPVs, which project should be chosen by the company. So now we are going to evaluate that which project is best for the company based on the calculation of adjusted risk adjusted NPV. NPV is net present value, and risk adjusted NPV is the method that basically incorporates risk into the standard net PV calculation by adjusting the discount rate to reflect the level of risk associated with the project. As you know that there are two type of rates are given. Here we have 12% for riskier project and 10% for less risky project. So this means that higher risk projects are discounted using the higher discount rate, while lower risk projects are discounted with a lower discount rate. This adjustment ensures that the riskier cash flows are valued less, aligning the evaluation with the risk tolerance of the company as a whole. So, this 12% is for project B, because you can see that here we have more standard deviation or more coefficient of variation, which means that project B has a higher risk as compared to project A. So the riskier project rate is 12%. So project B is going to be evaluated on the basis of 12%, whereas project A is going to be evaluated on 10% because project A is less risky. So this is basically the concept of risk adjusted NPV, because we actually calculate NPVs based on the calculation of risk of mutually exclusive projects. So the for the riskier projects, you can see the standard deviation is higher. Higher standard deviation indicates that project B is riskier as compared to the project A. So project B is going to be evaluated, or its NPV will be calculated on 12%. So this is the basically concept of risk adjusted NPV. So next step is to calculate net present value. So for the net present value, the formula is actually adjusted and risk adjusted NPV formula. Here we are going to calculate here risk adjusted NPV, and for risk adjusted NPV we have mm, here we have risk adjusted NPV, and we have you can say expected cash flows multiply by present value of annuity factor, and then this is one, and then we will deduct any initial cost. So here this is the formula of risk adjusted NPV. So for project A, expected cash flows, you can see the expected cash flows are this 6,750. So we have 6,000 6,750 multiplied by present value of annuity factor, and here present value annuity factor can be calculated in this way. Present value annuity factor, here we have this formula for present value of annuity factor, which we have derived with this. Here we have 1 divided by n means rate of interest. As project A is less risky, so rate of interest is 10%, which is 0.1, and n, because this project is for 3 years, it is mentioned in the problem, and again the rate of interest is zero point 0.1. So here we have the present value of annuity factor, which is 2.486. So we multiply this with 2.4868, and then we will deduct initial cost. Initial cost, you can see here we have this initial cost for both of the project 6750. So we are going to deduct 6750 from this. So here in the last step, this is your uh, adjusted risk adjusted net present value. So this amount will be in dollars, and here it is the answer. This is for project A. So the next, for project B, we are going to repeat the same, but risk fact present value annuity factor will be calculated again, as the percentage is different, or the rate is different. So here, instead of taking 10%, we are going to take it 12%. The time remains same. So the factor would be this one, 2.401. So risk adjusted NPV. Here we have expected cash flows 7650. So we have here, we have 7650 multiplied by present value factor, which we have calculated this one, 2.401831, which is based on 12%, and then divide by cost. Cost is same. So this is our risk adjusted NPV for uh, project B, and it is in dollar. So this is the second calculation. This is for project A, and this is for project B. So the last requirement is basically, what is the last requirement? If you knew that projects B cash flows were negatively correlated, so there's a negative correlation with the firm's other cash flows, whereas projects A cash flow were positively correlated, how might this affect the decision? So this is a qualitative analysis, and it is based on the correlation of the project. So if project B's cash flow are negatively correlated with the firm's other cash flows, this means that it provides diversification benefits and reduce overall risk of the company. And like for project A, cash flows are positively correlated. This means that it will increase all the risk, or it will increase the firm's risk. So If the project B cash flows were negatively correlated with GDP and project A is positively correlated, would that influence your risk assessment? So, yes, of course, because if we're talking about positive cash flows, this means that the positive correlation, like in the case of a project, so positive correlation with GDP aligns with economic cycles, which means that it could affect risk in economic downturns or in bad economic conditions. It will in fact increase the risk, overall risk of the company. Whereas in case of project B, which is negatively correlated with project B, with GDP, this implies that it perform well during downturns or during bad economic conditions. This means that enhancing the firm's stability or enhancing the firm's position overall. So, in conclusion, we can say that the portfolio effects from Project B would tend to make it less risky than otherwise. This would tend to reinforce the decision to accept Project B because, with the help of risk adjusted NPV, you can see that the Project B seemed more profitable as compared to Project A. And of course, well, you can see the uh, cash flows, expected average cash flows of project A are less as compared to B. So expected cash flows are higher in project B, as well as you can see adjusted risk adjusted NPVs are higher. So in part C, again the decision is to go with project B. If the project B were negatively correlated with GDP, so this means that it is less risky and project B's acceptance is reinforced. So we should go for project B, yes. So that's it from this problem. Take care, class.